An old thermostat has no battery, no computer, and no chip, yet it still senses 1 degree of change. There's no electronics involved at all. The whole trick is bolted onto 2 thin strips of metal that simply don't like the heat the same way, and that disagreement alone is enough to run your furnace for decades. Open one up and you expect wires, a tiny brain, something smart. Instead, you find a coiled ribbon of metal and a small glass bulb of mercury, or a plain pair of electrical contacts. That's it. No processor, no battery compartment, nothing you'd recognize as a sensor. So how does a bare strip of metal know when your room has crossed exactly the temperature you dialed in, and not 1 degree sooner? You might assume it's some kind of spring that just relaxes as things warm up, like a rubber band going soft in the sun. That's not it, and it's not close. A single piece of metal barely moves with normal room temperature swings. Heat a steel ruler by 10 degrees, and you won't see it budge. The real part doing the work is 2 different metals bonded together into 1 strip that disagree with each other. Every metal expands when it's heated, but not at the same rate. Brass swells more per degree than steel does, roughly twice as much for the same rise in temperature. Bond a strip of brass to a strip of steel, back to back, into a single ribbon, and heat the pair together. The brass tries to stretch farther than the steel next to it allows. Locked together, the strip has nowhere to go but to bow, curving toward whichever metal expanded less. That curving motion is the entire thermostat, and it starts small. Straighten the bimetallic strip out flat at room temperature, and it just sits there dead still. Warm the room by only a few degrees, and the strip quietly bends a fraction of a millimeter at a time, tracking the temperature almost like a tiny thermometer built entirely out of internal stress instead of a liquid column. A flat strip alone barely moves enough to be useful. So coil that same bimetallic strip into a tight spiral instead of a straight bar, and a small temperature change turns into a much bigger rotation at the tip. The same bending, multiplied by the length of metal wound into the coil. Attach that tip to an electrical contact or to a glass vial of mercury that tips over and closes a circuit, and one specific bend at one specific temperature becomes the exact instant the switch flips, calling for heat or shutting it off. There's no chip deciding when 68 degrees has arrived. The metal itself is the decision maker. 2 expansion rates, permanently bonded, physically disagreeing with each other, second by second, until the disagreement grows large enough to trip a switch. That's why an old mechanical thermostat can run for 40 years with no power source at all and still hold a room to within about 1 degree year after year. The same bent metal trick sits inside oven thermometers, curling toaster timers, and the circuit breakers that trip when a wire overheats. Dozens of everyday switches, all running on nothing but disagreement between 2 metals. No sensor, no software, just 2 metals that expand at different speeds, and a shape that turns that disagreement into motion. If that changes how you look at the box on your wall, stick around. We keep cutting things open. Subscribe at Cutaway 360.